Evaluate logarithms. Thinking question 4. Which is greater? Log to the base 6 of 7 or log to the base 8 of 9? So that's kind of a tricky question. So what we can do is we can convert the base to 10 for both and then try to compare, right? We can also evaluate thereafter using calculator and figure out which is greater. But I'll give you some other logic. So let's go with the first one, log to the base 6 of 7. This could be written as log of 7 divided by log of 6, correct? So it's a ratio of log of 7 to 6. And how about log 8, 9? So log to the base of 8 of 9 could be written as log of 9 divided by log of 8, correct? So it's again a ratio of log of 9 to log of 8. Now to help us answer this question, what we will do is we'll try to reason out from the graph itself. Let's say this is our graph for log to the base 10. Let me sketch one rough graph here. So it'll be kind of like this, going like this, right? So that's a kind of graph where this of course is at 1 and at 10 we will have 1, right? So okay, so we'll not bother about that in any case. But what we see here is, okay, let's say because the values are for x less than 10, so let me take this value here. Let this be 10 for us and this be 1 for us. So log, this is log x, right, to the base 10, and here we have x. So this is the kind of graph we have. One easy calculation is, of course, we can use a calculator. Let's do that first. Log of 7 divided by log of 6 is equals to 1.086. So this is actually equals to 1.086 if you calculate, and then we can calculate log of 9. We get this is equals to 1.05, right? So clearly we know that log to the base 6 of 7 is greater than log to the base 8 of 9. So that is from calculation. Now let's see from the graph itself. Now as you see the graph of log, it is always increasing. Do you see that? So what we notice is that the graph is always increasing, right? And as you observe, if you go into steps of 1, let's say if you take one step here, steps of 1, you know the slope is decreasing, right? And rate of change is decreasing. Do you see? Rate of change is decreasing. So as you go higher and higher, the difference between the consecutive values is lower and lower, right? And since this is the ratio of initial values, let's say somewhere here, let's say it is somewhere here, so this rate is more than the following rate, right? So that helps us to explain that log of 6 to the power 6 of 7 will be greater than log of 8, 9. Do you understand? So that is the kind of reason we can give from the graph, and that supports the calculated answer also. Thank you.